Stars, the fiery giants that light up our universe, have a fascinating and surprising life cycle. Although it may seem counterintuitive, larger stars live shorter lives than smaller ones. Dwarf stars, like our Sun, can remain on the main sequence for billions of years, fusing hydrogen into helium and maintaining a stability that allows them to enjoy a long life. In contrast, massive stars, which can be up to 100 times larger than the Sun, burn their fuel at an incredibly fast rate. While a star like the Sun can live for about 10 billion years, a massive star can exhaust its hydrogen supply in just a few million years. This rapid energy consumption leads to a series of explosive stages in its evolution. Once the hydrogen is exhausted, these stars begin to fuse helium into heavier elements, leading to significant expansion and the formation of red giants. Finally, these colossal stars culminate their life in a spectacular supernova explosion, dispersing their elements into space and leading to the formation of new stars and planets. This process not only contributes to the creation of essential elements for life, but also enriches the interstellar medium. Thus, in this cosmic cycle, the largest stars, despite their impressive size and brightness, leave their mark on the universe in a much shorter time. The contrast between the longevity of small stars and the ephemeral grandeur of massive ones reminds us of the beauty and complexity of stellar life in the cosmos, where each star plays a crucial role in the history of the universe. Neutron stars are the incredibly dense remnants of massive stars that have exhausted their fuel and exploded as supernovae. After the colossal explosion, the stellar core collapses under its own gravity, compressing protons and electrons into neutrons, a subatomic particle with no electrical charge, hence the name. Imagine a teaspoon of this stuff, it would weigh billions of tons on Earth. But these stars are not all the same. Pulsars, for example, are neutron stars that emit beams of electromagnetic radiation from their magnetic poles. These beams, like those of a cosmic lighthouse, sweep through space as the star rotates, creating regular pulses that we can detect from Earth. Magnetars, on the other hand, are neutron stars with magnetic fields billions of times stronger than those of our planet. These intense magnetic fields generate enormous bursts of X-rays and gamma rays, making them some of the most energetic objects in the universe. Neutron stars also exist in binary systems, where they orbit another star and suck in its material. This accretion process creates disks of hot gas that emit intense X-rays. And let's not forget millisecond pulsars, which spin at astonishing speeds, hundreds of times per second. This dizzying spin is the result of the accretion of material from a companion star. Each type of neutron star offers us a unique window into extreme physics, allowing us to study matter under conditions we can't replicate on Earth. They are true cosmic laboratories that help us better understand stellar evolution and the limits of physics. Imagine this: the light reaching your eyes from certain stars is not a reflection of the present, but an echo of the past, a message that has traveled unimaginable distances through space and time. Some of those lights you see every night began their journey millions of years ago, even before the first humans walked the Earth, before mountains rose or oceans took their present form. It's as if we're watching an old movie, where each frame shows us a distant moment in the history of the universe, a scene frozen in time that reaches us with a cosmic delay. The distance between us and these stars is so immense that light, the fastest thing in the universe, takes a very long time to reach us: years, centuries, millennia, even millions of years. For example, the light from some stars we see in the constellation Orion left more than 1,500 years ago. This means that when we look at those stars, we are seeing what they were like back then, long before the pyramids of Egypt were built or Rome was founded, a past that unfolds before our eyes like a cosmic spectacle. The light from other stars, even more distant, began its journey hundreds of millions of years ago, when dinosaurs ruled the planet, when life on Earth was very different from what we know today. So, the next time you look up at the night sky, remember that you are contemplating a journey through time, a window into a cosmic past that reveals the immensity and antiquity of the universe, a reminder that we are only a small part of a much larger and older story.